Look up at the night sky, and the stars appear to go on forever. But that endless canopy is an illusion. We are actually trapped inside a finite bubble of visibility called the observable universe, and an invisible boundary masks a much larger, unreachable reality. This image maps the timeline of cosmic history, ending with the marker for today, 13.82 billion years after the Big Bang. Because light has a strict speed limit, we can only see objects whose light has had enough time to travel across space and reach us since that exact starting point. This physical limit creates a spherical horizon around Earth with a diameter of 93 billion light-years. If an object is further away than that, its light simply hasn't had the time to reach our telescopes. To complicate matters, the space inside and outside this bubble is expanding. The physical distance between galaxies is increasing, causing the objects we can see to drift further and further away from us. As those galaxies recede faster and faster, their light will eventually fail to reach us at all. The universe we see right now is slowly disappearing, erasing its own history from the future night sky. This diagram shows our exact cosmic address. We start on Earth, nested within our solar system, inside the Milky Way. Following the path upward, our galaxy belongs to the local group, just one small cluster perched on the outskirts of the massive local supercluster. Zooming out, superclusters arrange into massive thread-like galaxy filaments, but they don't hold themselves together. An invisible substance called dark matter provides a gravitational scaffold, pulling glowing matter into dense strings that wrap around enormous empty voids. Every star, planet, and galaxy humanity has ever recorded is a component of this single, massive structural network. This is the cosmic web. You cannot put the cosmic web on a scale. So how cosmologists calculate the mass of everything inside our 93 billion light-year bubble? They use critical density, the energy density keeping the universe flat. Averaged out, it's an incredibly sparse 5 protons per cubic meter. Multiplied by the total volume of our observable bubble, the mass of all ordinary matter equals 1.5 times 10 to the 53rd power kilograms. But ordinary matter and dark matter only account for about 32% of the universe. The remaining 68% is dominated by a repulsive force known as dark energy. Dark energy pushes space apart. This force causes the universe's expansion to accelerate, aggressively stretching the physical space between galaxy clusters. Because the space itself is expanding, the objects riding along that space recede from us. At the outer edges of our observable bubble, these galaxies are being pushed away faster than the speed of light. This establishes a strict future visibility limit. If a galaxy crosses that boundary, the light it emits today will never be able to overcome the expanding space. It becomes permanently unreachable. That 93 billion light-year bubble is just the part we can see. The total theoretical universe extends far beyond our visibility limit. Based on cosmic inflation, the universe is at least 3 times 10 to the 23rd power times larger than our observable bubble. That is just a lower limit. Mainstream models suggest it has no boundary at all. It may be infinite. We are stranded on a microscopic speck. Everything we will ever know, measure, or interact with is floating inside an unmappable, endless ocean of space. Over billions of years, the gravitational glue of dark matter will lose its war against dark energy. The massive galaxy filaments of the cosmic web will dissolve, breaking apart as the space between them stretches. As these distant galaxies recede into the void, their wavelengths will stretch, turning redder and fainter. Eventually, they will slip past our visibility limit and fade into absolute black. Anyone looking up at the night sky in the far future will see a lonely, empty void. They will only be able to observe the stars within their immediate local galaxy, with no structural evidence that the rest of the universe ever existed. We happen to exist in a uniquely privileged window of time. We are here early enough to map the cosmic web, weigh the galaxies, and understand our place in the universe, before the expansion of space hides it all forever.